Hello everybody, welcome to this presentation. Today I will be talking to you guys about computer networks. The title of my presentation is Demystifying Computer Networks, a comprehensive guide for new interns. In this capacity, I am basically speaking as a senior network engineer for Wells Fargo Bank NA. And you guys are the new interns that will be learning a lot about computer networks and help us usher in our new network expansion at Wells Fargo. So stay tuned and listen. And we'll go ahead and get started. Thank you for joining the company. So welcome again, and let's move on. In fact, our presentation will mostly focus on unveiling the software and hardware components on concepts for network creation. And the purpose of this is to provide you guys with a comprehensive overview of computer networking fundamentals for our new interns here at Wells Fargo Bank. As the new interns, I hope that you will be well versed in everything about computer networking so that you will be prepared and up to speed to usher in our new network expansion here at the bank. So thank you again for visiting and working with us. So let's dive in. We're going to talk about the OSI and TCP/IP protocols. The OSI, or again, Open Systems Interconnection model, it's the conceptual framework for all of network communication. It's made of 7 layers, which comprise of application, presentation, session, transport, network, data link, and physical. Each one of these layers performs a specific function in data transmission and reception. It's also important to note that these 7 layers, are further subgrouped into 2, which comprise of the host layers, that will be the physical, data link, and network, and the media layers, which will include your transport, session, presentation, and application layers. On the other hand, the TCP/IP model, or the Transmission Control Protocol and Internet Protocol model, is the most prevailing model that's typically used in actual networks today. It's made of 4 layers, which will be a subset of the OSI model. These layers are application, transport, internet, and link. The focus of the TCP/IP model is on data transfer and addressing. Now let's look at network models from a different vantage point. We're going to look at basically the client-server network model, which again is a distributed network model, and of course where we have one computer, which is the server, that is charged with providing resources to other computers, which are known as clients in the network model. Examples of basically client-server models will include things like web servers, email servers, and file servers. Each of these models have important function in the network. And of course, the servers are the key store to the key resources that other connected computers or clients require. The other model, network model we're going to look at is the peer-to-peer model. In the peer-to-peer model, what we see here is that, of course, all computers are basically in the network will share all the resources directly with each other, therefore eliminating the need for a server. As such, all the computers are basically providing almost both the functions of a server and of course of a client, because information can be requested from them and of course be shared to them as well. Examples of this model would be found in file sharing networks and of course torrenting. Alright, now we will talk about network media. There are two components to network media that we're going to elaborate further on. First, the physical aspects, which will deal with cabling. Under cabling, you're going to deal with physical medium that transmit signals through wires of some sorts. In this case, we're dealing with examples like twisted pair, coaxial cables, and of course fiber optic cables. As you can see, coaxial cables were typically mostly used. However, there's a growing um, popularity of fiber optic cables because of the possibility of higher bandwidth that they offer. Some of the criteria that an individual would use to determine the kind of cabling that is required is how far does this network have to travel? What's the bandwidth requirements? And of course, how much would it cost? When we're dealing with a wireless system, on the other hand, we're dealing with signal transfer through electromagnetic waves. And the technologies that make this possible include things like Wi-Fi, Bluetooth, and of course cellular networks. However, wireless networks are completely not independent of cabling because a lot of the times we basically use wires to transmit the information and signals to a certain location, and then these other technologies will act on the periphery of cabling to provide the wireless technologies that are basically prevalent to this day. Some advantages of wireless technologies include flexibility, scalability, and ease of installation. Now we're going to dive further into this discussion. We're going to talk about network devices. These are devices that make computer networks possible. So let's get started with routers. Routers are intelligent devices that connect different networks. Like the name sounds, their main function is to basically route data packets based on the destination address. That is why the protocols that we discussed earlier, the TCP/IP protocols, are important because routers can only send information to the right address based on those TCP/IP protocols. Now, it's important that this were established, or else communication through computer networks would have been almost impossible. Now, the next thing that we're going to talk about are bridges. Again, bridges, just like the function of a typical bridge, connect two or more local area networks. Again, their main function is to be able to filter and forward data packets based on the media access control addresses on the LANs. And then the other device we're going to talk about is a hub. Well, just like the hub, the name implies, again, they operate at the physical layer of the OSI model, and their key function is to connect multiple devices together, which then allow them to communicate with each other. Okay, let's continue our discussion on network devices. The other three that we're going to talk about include repeaters, gateways, and switches. Repeaters help amplify network signals so that it can extend their transmission distance. Gateways, on the other hand, connect networks with different protocols or architectures. As a result, they play an important role in enabling the communication between incompatible or, in certain cases, dissimilar networks. And switches, on the other hand, operate at the data link layer of the open system interconnection model and functions by connecting devices and of course forwarding data packages to the intended recipient of that data packet. So they are basically, think of them as directors of information, relaying information and data packages to the right recipients on the network. So let's dive further into our presentation and look at network topologies. Again, network topology is basically, again, the physical and logical arrangements of nodes and connections in a given computer network. Some of the key example network topologies that you may hear of or might have heard of or know about include the bus topology and star topology. Other two would be ring and mesh topology. We're going to go into the remaining two later, but right now let's discuss bus and star topologies. In the bus topology, everything is connected to a central cable. All of the devices in that network would be found connected to a central cable. And the advantage of a bus topology is the fact that it's simple and very cost effective. The disadvantage, on the other hand, of course, it's a single point of failure, can basically disrupt the whole network, and of course, limited bandwidth. In a star topology, on the other hand, all the devices are connected to a central hub or switch. Now, the advantages that the star topology offers is that it's a centralized management system and, of course, ease of troubleshooting. Disadvantages, on the other hand, is that it relies on that central device for all sort of communications. Moving on to the other two types of network topology that I mentioned earlier, kind of alluded to. The first of the two that we're going to talk about now would be ring topology. In a ring topology, devices are connected in a circular fashion, forming a closed loop. Now, the advantages that this closed loop will offer is deterministic data flow and, of course, fault tolerance. Disadvantages, however, is, of course, it's a complex cabling and installation. Mesh topology, on the other hand, devices will be connected to multiple other devices, creating a redundant network. This advantage that basically would be found in a mesh topology is that the network itself would be highly resilient and scalable. The disadvantages, it's a very complex configuration and a higher cost of installation. Now let's move on to network operating systems, or NOS. The network operating systems are, of course, a specialized group of software that manages and controls a given network. Some of the key primary functions that NOS offers or are imbued with include user authentication, file sharing, network security, and resource management. Some examples of network operating systems include the Microsoft Windows Server, Linux, and the Unix-like FreeBSD from Berkeley. Thank you. That brings us to the conclusion of our presentation. Now, before we exit, here is the recap. We really talk about the essential components of a typical computer network, which includes the hardware, software, protocols, and models. We then went on to talk about understanding network devices, topologies, and operating systems. And most importantly, the importance of network design, implementation, and management. Now, what I would want you to be able to take from this and know is interns here are typically very actively encouraged to participate in the company's network expansion project, seek guidance from senior engineers, and utilize available resources. And of course, we encourage you to continuously learn and explore these key components, and that will be part of your key to success at Wells Fargo. With this, I will leave it to you guys to see if in case you have any question regarding anything about network, computer networks, or anything of that nature. If you do, please feel free to ask at this point. Thank you. And here are my references.